Hi everyone, welcome to Group 4 of the Titanium. Today we are glad to discuss this topic of the following points. You can focus on the mining, processing, and discussion. Firstly, let's think about what is the titanium. Titanium has the symbol of the Ti and the auto map of the 22. You can see this is photo. It is what light white survivor or great mentor. Although it is real find of the pure, but it is the third most abundance of mentor of the Earth's crust. Titanium mentors is reactive and has excellent corrosion restriction. Titanium ore is also widely used in the mining industry. What are the features? It means what is the physical property of the chemical properties. It has high stress, high sensitive stress, very strict of the corrosion, and has the low temperature performance and strong anti-damping performance. It's very active, but the no mechanism and no toxins. It may then have a mining production. And these features also made it has a significant mentor of the 21st century. Where we can find the titanium. We can see titanium is found mainly as the oxygen and silicon. It has 114 kinds of the titanium miners, and the amical and roots is the most common. You can see this chart shows you the global production and reserves. It is also observable that Australia and China had massive titanium resource. You can also see this is map they told you was the type and the distribution of the titanium deposits.
Hello, my part is divided into three parts: develop, process, main application, and industry trends. In the first part, it is essential to know that the usage is closely related to the global economy. What is more, the whole process can be treated as three stages. The first stage is from 1980 to 1900. The second stage is from 1994 to 2001. From 2004 to now, it is known that the international economy and aviation industry have developed rapidly with the increasing consumption. In the main applications part, from the pie chart shown right, 46% of the world's titanium concentration is used to aerospace field. 43% of titanium concentration is used to the industrial fields. Compared to these two fields, the rest is not as important as the former. In the industry chain part, from the flow chart, the last part is the ingredient, and the right part is application in the market. It is worth mentioning that titanium dioxide is playing an important role in the paint field.
First, we'll discuss the mining method. The mining method can basically be divided into two categories, the surface mining and underground mining. The surface mining is a form of mining in which the ore burden, such as soil and rock covering the deposit, are removed. This mining method can be implemented when the deposit is near and can be accessed directly from the surface. Different from the surface mining, the underground mining is considered when the deposit ore is too deep for the surface mining, or there is a restriction on the usage of the surface land. The deposit ore is accessed from the surface by the support of vertical shaft or horizontal eddies. Both mining methods could be used in combination if an outcropping ore body traps deep into the earth. Surface mining could be used at the beginning of the operation, and underground mining could be used later to continue the operation. Then we will look at the advantage and disadvantage for both the mining method. From the table, we can consider that the surface mining has more advantages than the underground mining in terms of cost, productivity, and safety. However, it causes more severe environmental impact than the underground mining. Therefore, the reclaiming of the post-mining land is required to make the surface mining more sustainable. In order to choose the most appropriate mining method for the titanium, we need to consider its availability and accessibility on the Earth. Since titanium is the ninth most abundant element in the Earth, and it exists in nearly all rock and sediment in the form of ilmenite and rutile, Hence, the surface mining is more relevant to mine the titanium to maximize the profit. In terms of surface mining, titanium can either be mined by using the open pit mining or wet dredging mining, depending on the type of deposit found. If the deposit is found in the crystalline rock or weathered rock, the open pit mining is recommended. If the deposit is found in the unconsolidated sediment or high mineral sand, the wet dredging mining is suggested. First, we will look at the open pit mining. There are two major hard rock ilmenite mines in productions in the world, which are Tunas mine in Norway and Lacteo mine in Canada. Both these mines is using open pit mining method to mine their deposit. The picture beside shows the open pit ilmenite mine in Norway. In open pit mining, the ore burden above the deposit is first being removed by the bulldozer and transported to the deposit site. The drilling and blasting process will then be carried out to fracture the rock that contains the deposit into the loadable size. The deposit ore is then loaded on the truck by hydraulic shovel and transported to the downstream processing site. Then we'll look at the wet dredging mining method. Both the Richard Bay mineral mine at South Africa and Moma mine in Africa are using this mining method to mine their ore deposit, as the deposit found is in the form of unconsolidated sediment and high mineral sand. The picture beside shows the titanium mining site in Africa. Similar to the open pit mining, the first process in the wet dredging mining is to remove the ore burden above the ore deposit. An artificial lake is then be created by digging below the water table and filling the water into it by the water pump. A floating branch with suction bucket wheel attached to it is used to remove the sediment from the lake bed. The sediment is then loaded into the truck for further processing.
Annual titanium metal consumption, only 5% goes to titanium metal production and the rest to titanium pigment industry. Through chlorination process, we convert titanium dioxide into titanium tetrachloride, which is required for the production of titanium metal. Initially, the oxide ores are reacted with chlorine in a fluidized bed of petroleum coke. Oxygen mixes with carbon in the coke to produce carbon monoxide and carbon dioxide, while titanium and chlorine react to form gaseous titanium tetrachloride. The X and Y in the given equation are variable quantities, which depends on the reaction temperature between 850 to 1000 degrees Celsius. Raw titanium tetrachloride is then liquefied and passed through the distillation column to remove volatile impurities at both high and low boiling points. Vanadium oxychloride, another impurity with similar temperatures as titanium tetrachloride, is stripped from the product stream by reaction with mineral oil. Titanium tetrachloride is then redistilled in a reflux distillation column to remove any remaining impurities. These separations lead to a high purity of titanium tetrachloride exceeding 99.9%, which is used to achieve high quality metal. In the production of titanium metal, titanium tetrachloride is either reduced with sodium in the Hunter process or magnesium in the Crore process. Hunter process is a two-step process taking place in two different reactors. Titanium tetrachloride is reduced at low temperature of 230 degrees Celsius to solid titanium dichloride in the first reactor. Then titanium dichloride and sodium chloride mixed is charged in the second reactor and reacted with additional amount of sodium at 1000 degrees Celsius to complete the reduction reaction. In the Crore's process, titanium tetrachloride is initially distilled to make it free from impurities such as iron and nickel. Then it is reduced by magnesium metal at 800 to 900 degrees Celsius to produce titanium sponge. Both Hunter and Crore process produce titanium in the form of highly porous material called sponge, with sodium chloride and magnesium dichloride trapped in the pores. The sponge is then crushed and the metal and salts are separated by high temperature vacuum distillation. These salts are then recycled through electrolytic cells to produce sodium and magnesium for reuse in the metal reduction and chlorine for reuse in chlorination of the ore. Some advantage of Hunter process is the continuous nature of the first step with low operating temperature, where materials of construction for equipment offer fewer problems. While for the Crore process, there is ready availability of reductant magnesium in the commercial quantities and at reasonable cost. Moreover, the feasibility of getting chlorine gas and magnesium recycled decreases the production cost.
The mining industry comes with its fair share of challenges, from scarce resources to uncertainty around commodity prices. Miners are always looking at ways to overcome barriers to stay competitive. Third parts explore the challenges and the possible solutions are divided according to the forward content. Safety Mining can be an extremely dangerous profession. The conventional occupational dangers of coal dust inhalation, hearing loss, and chemical hazards still exist. Accessible energy is usually a problem. Distant mines are turning to scalable microgrids. Access and allocation to capital is often cited as one of the biggest issues facing the mining industry, especially for its juniors. A study shows that nearly 10% of the energy generated is used on the mining industry. It is vital for us to reduce the carbon footprint and make it more sustainable. One possible way to solve such questions is put forward. Geothermal is by using the heat underground to heat the water and generate electricity. We can build a geothermal power plant around the mine, hence the energy could be used. What's more, once accident happens, the geothermal water vane could be a great choice to rescue. This is an example. It is apparent that geothermal technology has enormous potential to harness the heat energy in mines at all stages, from discovery, store closure, and beyond, by delivering low carbon heat energy that can partially replace the usage of fossil fuels. TiSL4, named as titanium tetrachloride, is important in the main titanium industry but dangerous. Breathing titanium tetrachloride can irritate the nose and the throat. Although no occupational exposure limits have been established for titanium tetrachloride, this does not mean that this substance is not harmful. Safe work practices should always be followed. Despite technological advancements that have made the industry greener, mining still uses significant amounts of resources, water, land, and energy, and often causes severe harm to the environment. Companies can use waste rocks in simple on-site construction, like backfilling walls and reconstructing mined terrain in a way that prevents soil erosion. Businesses wanting to become more sustainable could also upgrade to more advanced, durable equipment that lasts longer, reducing the turnover of machinery and decreasing the resources needed. As for the rehabilitating mining sites, it's not a difficult problem, but it needs everyone's endeavor. For example, it's possible to use biosolids to replenish depleted topsoil. Soil with biosolids, if seeded and watered, can produce vegetation capable of preventing further soil erosion within as few as 12 weeks.
The next part is about the conclusion. The first is the future trends of titanium. The two charts are sourced from TZMI. From the left chart, we can see the global titanium raw material continues to decline in recent years. The reason is that the high quality of natural rutile resources are gradually reduced. The output of titanium will rapidly decline in recent years, especially in Australia, which once accounted for about 80% of the global output of titanium raw materials, such as rutile and ilmenite. The right chart we can see is that the global titanium raw material supply shortage will exist for a long time. The next is about our summary. Hopefully, that has proved the useful introduction of titanium, including mining and processing methods and the solution of challenges. Going the surface mining route will almost certainly maximize profits. The choice of open pit or wet dirt relies on the sediments and soil conditions. Proceeding the reaction with high temperature and inert argon gas under rigorous operation and proper safety measures may be the best approach to generate titanium. The goal of these strategies is to make the mining sector more secure, sustainable, and lucrative. If you have any questions, please leave your thoughts in the comment section, and we'd love to discuss them together. These are our references for this presentation. Thank you for your listening.